Okay, can you see my screen? Yes, okay, good. Okay, so sorry about the lateness again. Today we'll be talking about fractions, decimals, and percents. So I think most of you already know what fractions are, hopefully, but we'll review them real quick. A fraction is a part of, I think we talked about this a little bit in ratios and rates a few weeks ago, but as you can see, a fraction is a part of a whole or a quotient of two numbers expressed as a over b, where a and b are whole numbers. So like, for example, 1/2 is a fraction. And then you can also write a over b as a divided by b, same thing. So like, for example, 3 of 5 cupcakes were eaten at dinner. So the number of cupcakes eaten would be 3 out of 5. So 3/5. Okay, so types of fractions. Um, one type of fraction is called a proper fraction. Normally, normal fractions are basically look like this. It's 3 over 5, so the top number is less than the bottom number. So that's what a proper fraction is. Improper fraction is when the top number is greater than the bottom number. So like example, 5 over 3 would be an improper fraction because 5 is greater than 3. And then all improper fractions, the value is greater than 1 because the top is greater than the bottom. And then mixed numbers are basically improper fractions that are made proper. So kind of like improper fractions. So like 5/3, if you didn't want the top to be greater than the bottom, then you'd put it off to the sides. So you'd make it, so for example, this is 7 over 3. You can make it 2 and 1/3. So basically, if you have a number 2 and 1/3, you just, this number multiplied by the bottom number, and then you add it to the top number. So it's 2 multiplied by 3. Oh, doesn't want to write. Okay, 3. And then you add it to the top number. That's 1. And then you write the bottom number. So that's 7 over 3. I'll give a better example. Hang on. Let me change this real quick. So for example, let's take our improper fraction 5/3. We can turn this into a mixed number by, since 5 is greater than 3, we can take a 3 out, so one of them. And then if we take 3 out of 5, there's 2 left, so 2/3. And then you can reverse this by taking this number multiplied by the bottom, which is 3, and then adding it to the top, which is 2, and your original number. So that's 5/3. So it's reversible. So mixed numbers are just basically like simplified improper fractions. Proper fractions are the normal ones when the top is less than the bottom. And then so just like know the definition of each of them. So like in math counts, if they're like express your answer as an improper fraction, then don't like change it into a mixed number and just leave it. Or if it's like express your answer as a mixed number, always remember to change it into a mixed number. Okay, this is a really important point. So the division of fractions, if you look at this chart, if you have a fraction a over b, and then you divide that by c over d, so it's just one fraction divided by another fraction, you basically multiply the two outside ones and then put them on the top, so a times d, and then you multiply the two inside ones and then put them on the bottom, b times c. So knowing this, try 2/5 divided by 3 over 17. Right, nice job, guys. The answer is 14 over 15. So basically, you multiply the two outside ones, which is 2 and 17, so that multiplies to 14. And then you multiply the two inside ones, which is 5 and 3, which multiplies to be 15. Whoa, that turned out weird. So the answer would be 14 over 15. Okay. Okay, so comparing fractions, decimals, well, comparing fractions. So the first part is really easy. The fraction, if they have the same denominator, the fraction with the larger numerator is larger. So basically, this is like logic. If they have the same bottom part, then the one with the bigger top part is going to be bigger. So like you know that 3/5 is greater than 1/5, and you also know that 3/4. Well, okay. You also know that 3/4. Well, for some reason it's writing really weird. Okay, you always know that 3/4 is going to be greater than 2/4, right? Right, that's just logic. So basically, if the bottom parts are the same, the one with the greater top part is going to be greater. Okay, the next part is if they have the same top part, then the fraction with the larger denominator is smaller. Since the denominator basically like makes it into how many parts. So if you have 7 parts of a whole, it's going to be smaller parts than if you have 5 parts of a whole. Like if you have a pizza, 1/2, each part is going to be greater than if you had a pizza and you divided it into 1/3. So 1 part of 1/2 is going to be greater than 1 part of 1/3. So the fraction with the larger denominator is smaller. Okay. Okay, so this is really useful. It's called cross multiplication. It works for everything. So like if the question was what's greater, 3/8 or 4/11, what you would do is what's called cross multiplication. So for example, we'll write 3/8 and then 4/11 over here. So basically you take this and then you go up. And then you take this and you go up. And then when you go up this way, so it's always going to cross upwards. And when you cross upwards, you multiply them together. So 3 multiplied by 11 is 33. And then when you cross this way, 8 multiplied by 4 is 32. And then after, so it's always crossing and it's going upwards. So 33 is greater than 32. So this fraction is going to be greater than this fraction. So it's like that. So for example, let's say 1/2 and 1/3. We can cross multiply like this, going that way, this going that way. 3 multiplied by 1 is 3. 2 multiplied by 1 is 2. 3 is greater than 2, so 1/2 is greater than 1/3. So that's called cross multiplication. It's really useful, good to memorize. So it's always crossed and going upwards, and you multiply, and the one with the greater multiplication is the one that's greater. Okay. We'll come back to this one. Okay. So try this question. Which fraction is larger? 65 over 67 or 76 over 78? You can use a calculator with if you want, because it kind of looks a little complicated. Right, the correct answer is 76 over 78. Nice job. So you can use cross multiplication. Let's go back to this actually. Okay. Some useful formulas. Okay. So if you don't want to use cross multiplication, this I think it's a little bit easier. So this is just one little like rule of thumb that'll always be true. So if you have a number m over n, and you add the same number to both the top and the bottom, so m plus k over n plus k. So that's just basically you add the same number to both the top and the bottom. That number would be k. Then this number is always going to be greater than your original number. And then the same thing goes for subtraction, except for if you have a number m over n and you subtract something from both sides, so m minus k over n minus k, this number is always going to be greater. So again, it's I don't know, I didn't really use this, but I think it might be good to memorize. If you add something to both the top and the bottom, the same number, then it's going to be smaller. And if you subtract something to the top and the bottom, it's going to be larger. Okay, anyway. We'll skip that one. Okay. Let's go back. Okay, so knowing that, see if you can do example 3b. So remember, if you add something top and the bottom, it's going to be smaller. It's going to be larger, and if you subtract something, it's going to be smaller. So both to the top and the bottom. You can also use cross multiplication, but I think that'd take a bit longer. Right, nice job, guys. The answer was 77 over 78. Okay, we'll continue onwards. Okay, nice job. Okay, so this is useful in math count. Sometimes they like to throw this out like towards the end of the round, like 30 or 28, 29. Okay. So the first one is probably the most useful of them all. So if you look at it, it says 1 over n times multiplied by n plus 1 is always going to equal to 1 over n minus 1 over n plus 1. So what does that mean? Okay, so example, if it said if you had 1 over 3 times 4, this is going to equal to 1 over 3 minus 1 over 4. So you'll see why this is helpful in a moment. So just memorize that 1 over, if two consecutive numbers, n and n plus 1, so they're right next to each other, it equals 1 over the larger number minus 1 over, or sorry, 1 over the smaller number minus 1 over the larger number. So like another example would be 1 over, let's say 5 times 4. This is going to be equal to, so 1 over the smaller number, which is 4, minus 1 over the larger number, 1 over 5. So what you have to remember about this one is it's going to be two numbers that are right next to each other. They're consecutive numbers, and it's going to be the smaller number minus 1 over the larger number, because if it was the other way, it'd be negative. So knowing that, let's say if it gave you a question like this. Find the sum of 1 over 1 times 2 plus 1 over 2 times 3, etc. until 1 over 49 times 50. So this is really challenging if you don't know like what you're doing, but if you do, it might be helpful. So see if you guys can solve this. All right, the answer is actually 49 over 50. Nice job to the people who got that, and I'll explain why that is because it's a little bit challenging. So let's scroll back up so you can see it. This problem, and this is what's going to help you solve that problem. So you see that each one is basically two consecutive numbers that are one is greater than the other one. So we'll just use this formula and see what happens, right? So for the first one, it's 1 over 1 times 2, right? Sorry, my pen's acting up today. Okay. So 1 over 1 times 2. This equals 1 half, sorry, 1 over 1, because you have the least number, minus 1 over 2. So then that's that one. And then let's do the next one, 1 over 2 times 3. Okay, that's a 3. That equals, so again, you take the least number, 1 half, and then minus the greater number, 1/3. And then you take, okay, so the next one would be what, 3 and 4. So 1 over 3 times 4. This equals 1/3 minus 1/4. So if you look at it, you can begin to see, this is a 3, sorry. You can begin to see kind of like a pattern. If you sum all these together, look, so these two right here will cancel out since you have a negative 1/2 and a positive 1/2. And then these two right here also cancel out since you have a positive 1/3 and a negative 1/3. And then this one is going to cancel out with this one. And it's going to continue until you at the very end have 1 over 49 times 50 is going to equal 1 over 49 minus 1 over 50. And then this 1 over 49 is going to cancel out with the 1 on top. So you're going to be left with 1 minus 1 over 50, which equals 49 over 50. So again, basically you just write it out and see if you can find like numbers that cancel out in the end, and then you just cancel all of them out, and then until you get 1 minus 1 over 50. So that's kind of hard, but it's like good to know. So you can go back and review these notes. This is a little helpful, bit more helpful in higher up math, but I never really use these in Mathcounts or the SAT, so this is probably the best one to memorize. Okay. So types of decimals. So there are two types of decimals. So there's the terminating decimal and the repeating decimal. So if you look at the words, it's like terminating, repeating. So terminating means it stops. So like 1/4. If you punch that into the calculator, you get 0.25. 25. Oh my God, what is happening? You get 0.25. So that terminates, right? So it just stops right there. However, if you put 1/3 into the calculator, it'll give you a string of numbers 0.333333 onwards. So just a bunch of threes. So that's called a repeating decimal. So this is a terminating decimal, and this is a repeating decimal. So basically, if you divide it out, what number you get in the end. So if it stops, then it's a terminating decimal. If it continues, then it's a repeating decimal. So for example, if you put 1 over 17 into the calculator, you get 14287 and then 14287. So basically it repeats on 14287. And you write this like with a bar over the top. So like 1/3, this can be written as 0.3 and then with a bar. So that just signifies that the 3 is repeating. And then 1 over 17, you write this out with a bar. So it just signifies that after this ends, it's going to repeat again. Same thing for 1 over 13. Okay, we're going to skip this. Skip this. Okay. So see if you can do this one real quick, and then if not, I will explain it. Probably won't be able to do it, but it's okay. Okay, yeah. So convert 1 over 0.1 repeating into a fraction. Right, the correct answer is 1/9. Good job, guys. I don't know if you calculated that or you knew by like experience that if you divide 1 over 9, you get 0.1 repeating, but I will show you how to like calculate it. So this is kind of a solution, and I'll explain it off to the side. So first you set x equal to your repeating decimal. So x equals 0.1 repeating. And then you multiply both sides by 10. So why do you multiply by 10? Because once you multiply by 10, let's multiply by 10 real quick. So 10x equals, now it's 1 point, and then 1, 1, 1, 1, repeating onwards and onwards and onwards, right? So once you do that, now right over here, you have another x, right? So you just convert that into x. So 10x, where that 10 went, equals, so that's 1 plus, and then now you have again 0.111 repeating and onwards, and then that's what x is equal to. So that's x. So then you get x equals 1 over 9. So that's like how to calculate it. I'll explain it again real quick. So we multiply by 10 because that's how long the period is. So that's so we get x again over here with the 1 added to it. So like if it had a period of 2, I would multiply by 100. So then I could have the original number back to like where it is. So like back to where it is over here, where it repeats by 1. And then that's what x equal to. So I set that 1 plus, and then that's our x, and then x has to be 1 over 9. So knowing that, try this one. I don't know if you guys will get it, but if you don't, that's okay. I'll explain it, and then you guys will know it. So see if you can do this one, using the same concept as up here. Okay, nice job to those two who got it down there. The answer is 25 over 99, but it's okay. I'll explain it for the rest of you guys. So I don't know if my pen will start working or not. Okay, 0 over 25 repeating, right? So like before, we're just going to set this to equal to x, and then 25 is pretty. And then so basically we want to get it back to x. So instead of multiplying by 10 this time, because if we multiply by 10, it's not going to really help us, because then it'll be like starting with a 5 and then repeating 2 5s, so that's not going to help us. We'll multiply by 100, so it's 100x x equals, now it's 25 point and then 25 repeating. So if you can see how I did that, this would be, if I were to write this out, okay, so let's not let it equal x for now, and then let me write it out. So this would be 25, 25, 25, 25 repeating, and then onwards. So once I multiply by 10, I move this over 2 spots, 1, 2, now it's 25.252525, so right here. And then we already know that right here, 0.25 repeating is equal to x, so we can let this equal 25 plus x. And then move x to the other side, so we get 99x. Oh my, 99x equals 25. And then we have x equals 25 over 99. So again, so we identify how to get it back to 0.25 after we multiply it by a multiple of 10. So if we multiply it by 100 two times, then it goes back to 0.25 repeating, and then we replace that with our original x, and then we move the x to the other side, and then we divide. Okay, so using that, see if you can do what is, let's say what is 0.2 repeating. What is that equal to in fraction form? Right, nice job, guys. The answer is 2 over 9. So again, just real quick, you had 0.2, and then that we'll set that, we'll set that equal to x, and then we'll multiply both sides by 10, since it's just repeating by 1. So it's 10x equals 2.2 repeating. So then 0.2 repeating is going to be equal to x, so we can set that as 2 plus x, and then we move x to the left-hand side, so we get 9x equals 2, and then x equals 2 over 9. Sorry, my pen is messing up today, so it might look a little sloppy. Okay, so let's try 5.5 repeating. Right, nice job, everybody. The answer is 5 over 9. All right, so I hope you guys are kind of seeing the pattern to it. So anything point x repeating is always going to equal x over 9. So that's just a general rule of thumb. So anything point x repeating is going to be equal to x over 9. So like, for example, what is 0.6 repeating? You guys should be able to know this instantly. What is 0.6 repeating? Right, 6 over 9, or 2/3. Nice. You can simplify that as well. Okay. How about what is 0.37 repeating? Right. The answer is 37 over 99. You can take the long way, set this equal to x, and then multiply both sides by 100. So you get 100x equals 37.37 repeating. And then we see that 37 can be 0.37 repeating can be set as x. So it's x plus 37 equals 100x. X equals 37 over 99. But also another rule of thumb is anything with point AB repeating decimals is going to equal to AB over 99. So that's another rule of thumb. So how about what is 0.123 repeating decimal? going to equal to in fraction form? Right, you can simplify it. Nice job. So good job, guys. That's the answer. Um, you can see there's like a pattern. It's the number of digits that are repeating, it's the number of nines on the bottom, and then the number on the top. So that's just a general rule, a good rule. Okay. So see if you can calculate this. Um, 3.14 with the 1.4 repeating plus 0.32 with the 3.2 repeating. You can do this two different ways. So I'll give you guys a little bit of time on this. Okay, nice job to the two that got it. Golden, I think you were a little bit off, so maybe a miscalculation, but I'll explain it. Okay, so there's two ways of approaching this. So the first way is just straight up add it up. Okay, so let me write it out. So it's 1, 4, 1, 4. Sorry, I'm writing a little slow because the pen is really weird today. Okay, so 1, 4. Okay, that's a 4. And then repeating. The other one is 0.32 repeating. 3, 2, 3, 2, 3, 2. So let's start adding them up and see what we get. So the 3 plus 0, that's very normal, 3. And then 1 plus 3, that's 4. 4 plus 2 is 6. 1 plus 3 is 4. 4 plus 2 is 6. 1 plus 3 is 4. So you see there's like a little pattern. So it's 3.46 repeating. So you can either do it this way. This way only works if you don't carry. So there's no carrying involved. So this way works. But there's also the second way, which is the fail-safe way. It always works. So we turn this into 3 plus 0.14 repeating, and then plus 0.32 repeating. And then we turn these two into fractions. So these two can be turned into fractions. So 3 plus 14 over 99, right? So careless errors are easy to make. And then, sorry, oops. And then plus 32 over 99. Sorry, my handwriting's so bad because the pen is weird. Okay. And then you add these two up, and then you get your answer. So 46 over 99, and then that's 0.46 repeating, and then 3.46 repeating. Okay. So this is just repeating this. Okay. So we've already talked about fractions and decimals, so now let's talk about, oops, percentages. Okay. So a percent is basically, oh no, low battery. Okay. I'll go through this, read it, and then I'll go get my battery charger. Okay. So a percent is basically a fraction that has 100 as the denominator. So hundreds are per hundreds, and then also percent change. A number is changed from value A to the number B, so there's a percent change increase, it's okay. So you guys can read this, and I'll see. Okay, I'll let you do this problem. If you can see it right here, 25% of what number is 30? So try this problem right here, and then I'll be right back. So 25% of what number is 30? And I'll come back and explain it if you guys don't get it. Right, the correct answer is 120. Nice job. Um, we'll go back to how to explain this one in a moment. Okay. Okay. So this is basically the most important thing right here. Translation of words into math symbol. I find this really helpful. So it says, okay, so when it says what number, that's x. And then is equal, it's an equal sign, and of is a multiplication sign. So, like for example, our question was 25%. So let's write it. 25. So 25% is always 25 over 100. And then of is what? Multiplication. So 25% of, and then what number is x? So x is this. 25% of x. What number x? Sorry, what of is multiplication, and then what number is x? Is equal to sign 30. So now we just interpreted these words into symbols. So it's 25% of is the x, or the multiplication sign, and then what number is the x, and then is the equal sign, and then 30. So now this is relatively simple, easy to solve. So it's 25 over 100 multiplied by x equals 30. We multiply both sides by 100 over 25 to get x to itself. So it's x equals 30 times 100 over 25. Oh my God, sorry, 25. And then this is just 30 times 4, which is 120. So do your best to memorize this chart. What number is x, is equal to sign, and of is the multiplication sign. Okay, so what number is 25% of 1969? So try that. So the question is, what number is 25% of 1696? So again, try to use the chart. Oh, you guys can't see the chart, can you? Oops. Okay, so try to use the chart up here, and then find what number is 25% of 1969. So again, remember what number is x, is the equal sign, and of is the multiplication sign, and just translate those words into like a mathematical line. Right, nice job to you two who got it down there. The answer is 424. So again, we can translate this into what number is x is the equal sign. 25%, so 25 over 100 of is multiplication, and then 1696. So it's just 1696 divided by 4, which is 424. So again, remember this little chart right here. What number is the x sign is equal sign of multiplication sign? Okay. Let's try this problem. The price of a skateboard is reduced 20% for the spring sale and then marked up 20%. What fraction represents the new price compared to the original? This is from Mathcounts handbooks, by the way. All right, let me give you guys a little hint. When you reduce it by 20%, so it goes down 20%, that basically means it's now 80% of the original price. So if you reduce it by 20%, what it really means is now 80% of the original price. And then if you mark it up by 20%, what it actually means is now 120% of the original price. So I hope that makes sense. Because if you take it down 20%, what it actually equals is 80% of what your price is because you took it down 20%. And if you increase it by 20%, it's now 120% of the original price. So like if you discount something by 10%, what it actually means is you're taking 90% of your original number. Okay, nice job to those two down there who got it. Answer is 24 over 25. Or 96%, yeah, that works too. Okay, so I'll explain it for the rest of you guys. It's okay. So the price of the skateboard is reduced 20%. So like I said, when you reduce it by 20%, it basically equals 80% of the number. So it's 80%, so 0.80 of x. So this is now its price at the moment. Since you took it down, so let's say the price was originally x, and then you reduced it by 20%. That basically means that now you only have 80% of your original because you took 20% off. Now you have 80%. So it's 0.8x. So that's now the price of what you have. And now it says, then it's marked up 20%. So now you put it up 20%. So this is your original, this is now your number. And then you put it up 20%. So now it's 120% of your original because you took it up 20%. So now it's 120 over 100x. And then x was this price over here. So now it's just basically 0.12 times 0.8x. And then that is 24 over 25 or 0.96 of x. That might be a little hard to understand, but again, I'll explain it. you took it down 20% initially, so x, if you take something down by 20%, what you have remaining is 80% of x, so 80% x, and then you took this back up 20%, and if you take something up an x amount of percent, it's 1 plus that x amount, so it's 120% because you took it up 20%, and then that multiplied by 0.8 for your answer. Okay, so let's try this. Let's end this class with this number, or this problem right here. Given that 1%, so remember the chart up here. X is what number, and then is equal to sign, and of is x. So this is like in context multiplication. Okay, so let's try this one again. Given that 1% of 1% of a number is 5, what is the number? So just use that chart and just directly like transcribe it into numbers and then solve the equation. Right, nice job, guys. The answer is 50,000. I'll explain it again real quick. So given that 1%, so you write that 1%, and then of is multiply sign of 1%, so it's 1% again, and then of is multiply, and then a number is x, and then is equal to 5. So now we just solved this equation. 1 over 100 times 1 over 100 times x equals 5. So once you solve that, you get x equals 50,000. Anyway, sorry about the lateness and the pad messing up today, but that's going to be the end of today's class. Notes will be posted online, and I'll see you again same time next week. Bye.